Hello, good afternoon. I have prepared a readiness prep survey because I'm concerned about what you have prepared in order to do well in the course. Check your Canvas and always email me to let me know that you are participating. I will be making videos using various media to complement our learning experience. I do want you to study at least 2 hours for every contact hour. And you can feel free to email me and I will respond. I want you to review all earlier material. But remember, I will be lecturing on new material using this new format. For example, the first module is about real numbers. Real numbers are all the rationals and all the irrational numbers. The real numbers are what we call uncountable. A set is countable if you can put it into a one-to-one correspondence with the counting numbers. The counting numbers are 1, 2, 3, 4. And if you can match the elements of the set with the counting numbers, you call the set countable. But when the set is uncountable, like the real numbers, you have a couple of things going on. First of all, there is no first real number, and there is no last. It's infinite. And the real numbers are what we call dense. Between any two real numbers, there will always be another real number. If I have a number line and I give incrementation to it and put a number 1 and a number 2, what I realize is between any two real numbers, there's always another real number. So if I say this is 1 and this is 2, that won't work because I could move closer and that could be 2 and so forth. So we say the real numbers are uncountable. There are more real numbers than counting numbers. We have in mathematics something called cardinality of a set. The cardinality of the counting numbers was assigned Aleph Naught. It's a Hebrew letter, but that's the symbol for the cardinality of the counting numbers. Years ago, when I was studying with a book written by Natanson, a Russian mathematician, I learned that the cardinality of the real numbers is C, and C is greater than Aleph Naught. Now, even though our focus will be real numbers, there are subsets of the real numbers that we have been exposed to. You have the natural numbers, a subset of the real numbers. The whole numbers, starting with 0, a subset of the real numbers. So if we use a Venn diagram, we can draw circles with various radius. And if a circle is inside of another circle, the one on the inside is called the subset, and the larger one would be called the superset. Although we are studying the natural numbers, the whole numbers, the real numbers, I want you to know there's always more. The real numbers are contained in a superset called the complex numbers. And since I like to stretch your imagination, the complex numbers are contained in a superset called quaternions. And it goes on and on. The quaternions are inside of the octonions, and it goes on and on. But if we just master the algebra and the arithmetic of the real numbers, that is fine. But I want you to know there's always more. Now, when you have your set of numbers, you also define what we call operations. For us, we're going to focus on the binary operations. The binary operations are adding, subtracting, multiplying, and dividing. You need at least 2 elements in the set to carry out addition, subtraction, multiplication, and division. When you build a number system, you have the elements, your numbers, you have your operations, the four that we're focusing on today, and you also have properties. For example, the real numbers are what we call comparable. You can always decide which one is greater than the other, or if they're equal to the other, or which one is less than the other. So that's a trichotomy. 3 ways to compare real numbers. A can be less than B, A can be greater than B, or A can equal B. Now I'm telling you this, and there are some number systems where you do not have that comparability. But if we just remember that we can always compare real numbers, I'll be happy. Next thing, you have some other properties like the reflexive law. A number is equal to itself, A equal A. Then you have symmetry. If A is equal to B, B is equal to A. And then you have another property. If A is equal to B and B is equal to C, then A is equal to C. And then you have other laws and properties you need to learn. The identities. 0 is the additive identity. A plus 0 equals A for any real number A. A multiplicative identity. 1 times A equals A. You have commutative laws. The order of addition does not matter. A plus B is equal to B plus A. You have a commutative law for multiplication. A times B equals B times A. You have the associative law, where you shift parentheses. A plus the quantity B plus C is equal to the quantity A plus B plus C. And when I say quantity, I'm signaling the use of parentheses. And you have an associative law for multiplication. A times the quantity BC is equal to the quantity AB times C. Now, I want you to read your textbook and study your modules and complete all your work in the modules. And feel free to text me or email me. Thank you very much for spending time in this beautiful experience today to learn mathematics. Professor Jacqueline Brannon Giles.